Hey, statistics students, here is lesson one for chapter 8, and the big idea for chapter 8 is confidence intervals. And if this chapter were split up into three main sections, the first lesson would be just kind of some basic confidence interval vocabulary and what's going on with the confidence interval. And then lesson two will be all about doing confidence intervals with proportions, and then lesson 3 will be doing confidence intervals with means. So this mirrors very much chapter 7 and what we did back there. So here in lesson 1, it's got a lot of stuff going on, so it's a little bit long, but most of the example problems go pretty fast. Learning target 1 and learning target 2, just telling what is the difference between a confidence interval and a confidence level. And then probably the big thing is learning target 3, determine the point estimate and margin of error for a confidence interval. And then a couple of additional things describe how the sample size and confidence level affect the length of a confidence interval. We'll call that length M. And then learning target 5, explain how practical issues, things that we've talked about before, like response bias and convenience sampling and non-response can affect a confidence interval. So that's what we've got here in lesson 1. So first of all, a couple of basic things. What is a point estimator? Well, that's the chosen statistic for a parameter. Okay, so you've got a parameter, and whatever statistic we choose to measure this with, that is called your point estimator. And then the point estimate is the specific value of the estimator. Okay, so you would have a point estimator. That would be whatever you were working with, whether it's parameter or sorry, not parameter, but whether it's proportion or mean or variance or something like that. And then the point estimate would be the value of that proportion or mean or variance. We've got, again, we talked about that in the learning targets. We've got two big things. We've got confidence intervals and confidence levels. Okay, the confidence interval is the range of values that is likely to contain an unknown parameter. Okay. And so the way that you're going to find that is you're going to take your statistic and then plus or minus your margin of error. And your margin of error is simply going to be your critical value times your standard deviation of your statistic. Okay, so margin of error is your critical value, and your critical value can just be the number of standard deviations that you are away from your mean, and so your critical value times that standard deviation of your statistic. All right, and again, what is the confidence level? How is that different than the confidence interval? Well, the confidence level is the percent of confidence intervals that contain the population parameter. Okay, so your confidence interval will hopefully contain the population parameter, but the percentage of the confidence intervals that you've got, so you could have an infinite number of confidence intervals because you could have an infinite number of samples that you're taking most of the time. And so however many confidence intervals we have, the percent of those confidence intervals is that contain the population parameter. That's going to be your confidence level. And there is a big connection because your confidence interval will likely be your, the same percent as your confidence level. So if I had a confidence interval of 95%, well, it's essentially saying 95% of my confidence intervals will contain that population parameter. All right, well, let's get to some of these examples. So for exercise 1 here and 3, determine the point estimator, and then what is the point estimate. So we'll just get a handle on what is the difference between those two things first. So we've done this problem before earlier in the year. How many pairs of shoes on average do female teens have? We've got that down here. This was an SRS, simple random sample of 20 female students. And so here's the data. So this question you'd ask yourself, is this categorical or quantitative? And if it's quantitative, which this is, then we would likely want to use, so we'll say the point estimator, would be mean. Right? Although, you might also think about things like median. If it looked like there might be some outliers, we might want to use the median. Okay, but I think mean is probably a good estimate here. And then the estimate, okay, would actually just be the mean of these numbers. And so if we total them all up, I believe we would get 607, and there's 20 individuals, so divide by 20, and the mean would be 30.35. So if we chose mean as our point estimate, our estimator, then the point estimate would be 30.5. All right, the second one down here, different problem, going to the prom. Tanya wants to estimate what proportion of the seniors in her school plan to attend prom. She interviews 50 people of the 750 total in her school and finds that 36 plan on going. So again, you might think, is this quantitative or categorical? And this is categorical. It's binomial. People either want to go or they don't want to go, and so the estimator is not going to be mean. We would say it's the proportion. And the estimate is going to be the proportion that are planning on going, and that's 36 out of the 50, so that would be 0.72 or 72%. So hopefully that clears up any confusion that you had about estimators and point estimates. All right, so here's kind of it's got a lot of background to it, but we'll just briefly go through that. So there's this test, the NAEP, that measures basically how much common sense you have when it comes to math. And so scores can range from 0 to 500, and it gives you some examples of what you could do if you had those scores. But when it comes down to it, down here is the information that we need. We've got an SRS of 840 people from a large population, and the mean is 280, and the standard deviation is 60. Now, you got to keep in mind, the whole point of this chapter is we don't know these things. We don't know the mean and the standard deviation of the population. And so this is, I guess, just an easy way in because the whole point is that we don't know these things. But for right now, it's going to be nice to be able to compare back to the real mean and the real standard deviation. So the mean of my 840 scores will vary if you take repeated samples. Okay, so describe the shape, center, and spread of this sample. So it's like cuss without the U. So the center, well, the center is going to be the same as the population, and so the mean is 280, and so the mean of my sample is also going to be 280. So we'll say mu of x is 280. And then the shape, okay, well, because our sample size is bigger than 840, we can, or sorry, it's 840, so it's bigger than 30, we can go ahead and assume that it's going to be approximately normal. And then the spread would be the standard deviation. Now, the temptation is going to be to say that the spread is 60 for standard deviation, but of course, that's the standard deviation of the population. Here, this is, we want the standard deviation of our sample, and since this is quantitative, we're going to want the standard deviation of that, which remember was the original standard deviation divided by the square root of our sample size. And in this case, we would have 60 over the square root of 840, and that would turn out to be, what was that there, 2.1. Okay, so there is the center, shape, spread of our distribution. All right, and that right there is just straight out of chapter 7. All right, B, sketch the sampling distribution of x bar. Mark its mean and then the standard deviations away from that. So I'm going to be running out of space here pretty fast. So I'll try to squeeze all this in, but here is the shape of it. So approximately normal. We'll drop here and down here. Okay, so the mean, we already saw that that's 280, so 280 goes right here. And then since our standard deviation is 2.1, we'll just go 2.1 up for each of these. So 282.1, this isn't going to fit real well, but 284.2 and 286.3. And then if we go to the left, we're going to get 277.9 and then 275.8 and then 273.7. So sorry that's all squeezed in there, but I think you get a pretty good picture of what that is. We've seen that before. We saw that way back in chapter 1, chapter 2. So now for part C, now we're getting into some stuff from this chapter. According to our 68, 95, 97, 99.7 rule, 95% of all the values of x bar lie within a distance m of the mean of the sampling distribution. What is m? So 95% is going to be in between the top and the bottom two standard deviations. And so what is the difference in between here and here? And so we'll just say m is equal to, well, let's see, we'll just say 284.2 minus the standard deviation, two standard deviations away on the other side, 275.8, and that would be 8.4. Okay, so m is the distance of the mean of the sampling distribution. And then it says shade the region on the axis of your sketch that is within m of the mean. So that would be this right here. Okay. And then D, whenever x bar falls in the region you shaded, the population mean lies in the confidence interval, x bar plus or minus m. So, for what percentage of all possible samples does the interval capture mu? Well, for part D here, we're just going to say about 95%. So this right here is a question asking about confidence level, really. So, the population mean of the confidence interval, what percentage of all possible samples? So here's one sample. That's one sample, and 95% of all the samples that I take, assuming I took many, many samples, would capture this mean, the true mean right here of 282. All right. The next one continues working on this. It says, below your sketch, choose one value of x bar inside the shaded region and draw its corresponding confidence interval. So I'm just going to do a quick sketch of it. I'm not going to have all of the stuff here. All right. So our original one here, obviously this interval contains the true mean being this one down here. But anything that would contain that would be this distance m, okay, would wind up containing that. So this works, that contains the true mean, that contains the true mean. I would actually have to have everything outside of it for it not to contain the true mean. So that's an example. I guess these are examples. Here's a counterexample of what counts. All right. Prayer in school. So you've got this survey, and they're asking this survey whether or not you would prefer for there to be organized prayer in public school. So based on this poll, it says the 95% confidence interval of the population proportion is 0.63 to 0.69. So the low end of the spectrum is 0.63 and the high end is 0.69. It says interpret the confidence interval. Well, the confidence interval, here is my confidence interval. So here's basically the phrase that we're going to be saying. We're going to say, we are 95% sure that the true, let's see, and then the true proportion is between 63% and 69%. Okay? And so that's what it means to interpret a confidence interval. Part B, what is the point estimate that was used? Well, the point estimate is that actual value that we're guessing would be the true proportion. And so basically we just take the average of these things. And so it's going to be 0.63 plus 0.69 divided by 2 is equal to 0.66. So there's our point estimate of the true proportion. Does it mean it's the proportion? No, but it's our point estimate of it. And then what is our margin of error? Well, if this is right in between, well, I guess all we'd have to do to find the margin of error is just go 0.69 minus 0.66, and we get 0.03. So basically, it's plus or minus 3%. If this is my point estimate, this is what I'm telling people my guess is of the true proportion. I've got 3% above to the 0.69. I've got 3% below to the 0.63. C is based on this poll, a reporter claims that more than 2/3, or 0.66, of U.S. adults favor the amendment. What do you think about this? Well, it is true that our point estimate is 0.66, and sure, we could guess that it was higher than that. It certainly could be. However, we still have this pesky minus 3%. So we'll say, what about the bottom margin of error, the 0.63? 3, 2.66. He's not taking that into consideration. So I would say no. I do not accept the claims. In that there's still 3% that, the 3% that's below the point estimate. All right, this is a good question. It says, how confident? Just, again, getting to what is the difference between confidence level and confidence intervals. So here we've got a whole bunch of different confidence levels. We've taken samples, and then we've got a confidence interval for each of these samples. And here it says, which confidence level do you think was used? And we have to pick from these here. Well, remember, confidence level is the proportion of confidence levels that capture the true mean, and here's the true mean right here. So we're looking through and looking for ones that don't capture the true mean. You got one there. Let's see, the rest all look pretty good. Here's one more. Going down here. Oh, here at the end we've got 2 more. And so we have 4 that are not, and if we did 25 samples, we've got 21 that contain the true mean, and then we've got 25. And so this would be about 84%. And, well, I guess if I had to guess one thing, I'd say 80%, but really it could probably, you could make an argument for maybe 90%. You'd have to do more samples to actually see what the true confidence level is. But I guess for this particular one, we'll have to say 80% or maybe 90%. All right, moving on. Prayer in school. So back to that question. The news article goes on to say the theoretical errors do not take into account additional error resulting from various practical difficulties in taking any survey of public opinion. So obviously, we talked about this when we talked about some of the learning targets. It says list some of the practical difficulties, and we came up with some of these in class today, and some of them were quite good. We talked about response bias. Some people might feel pressured to say yes, that they are in favor of prayer for school, or they might feel pressure to say no. It's a pretty difficult thing, and so unless it were anonymous, people might feel pressure to respond one way or the other. Another one that we came up with was convenience. If you were located in the Bible Belt in the South, and you only surveyed people. So we'll say survey in one part of the country. So again, people in the Bible Belt, those people are probably more likely to be in favor of it. And if you went to a place of the country that was maybe a little bit more liberal, they might not be in favor of it. So convenience might be a thing. And then I came up with one, non-response. What if you made the call on a Sunday morning when people who would likely be in favor of this would be at church? Well, they wouldn't be there to take your call. And, there we go. So they would be underrepresented. So, all of these would be some reasons why, in addition to the plus or minus 3 percentage points for the margin of error, which just comes from mathematical margin of error, you might have these things in addition to that might make the margin of error larger. All right, and then finally, here, back to the shoe question. Now they want to compare boys to girls. So you took an SRS of 20 boys. And again, 95% confidence interval for the difference in the population means is 10.9 to 26.5. So what does this mean? Well, again, remember, we're not doing the means by themselves anymore. We're doing the difference of the means. The means of the girls minus the means of the boys. And so again, we'll go back to our trusty statement here, we'll say we are 95% sure that the difference in means of shoes for boys and girls is between 10.9 and 26.5 pairs. Okay, so we're 95% sure that the true difference between girls and boys' pairs of shoes owned is between 10.9 and 26.5 pairs of shoes. And then it says, interpret the confidence level. Okay, well, the confidence level would be 95% of confidence intervals. Okay, here we had one confidence interval. We are 95% sure that, or 95% of confidence intervals will contain the true difference of the means. Okay. And then the very last one here, does the confidence interval give convincing evidence of a difference in the population mean number of pairs of shoes for boys and girls? Well, if I were to kind of draw it out and do one of these interval things, the bottom interval is 10.9 and the top interval is 26.5. And for there to be no difference, 0 would have to be in here. That would mean there was no difference. And you can see we're 95% sure that this confidence interval, like the minimum difference would be 10.9. And we're 95% sure that all of these would contain the true mean. So yeah, we are pretty sure that there is a difference based on this. All right, well, that was a long lesson, but hopefully you get the difference now between point estimate, point estimator, between confidence levels and confidence intervals. We'll be talking about all that in regards specifically to proportions